again. My name is Carol Little. Please call me Carol. I just had a student walk up to me and said, I don't know your name, I just call you Miss Bath. I've been meeting with you for 3 months and you don't know my name, but he had a way of addressing me that I felt was polite enough. I hope you're here for 4th grade. 4th grade is a really interesting grade because it's right in the middle. They have learned how to multiply and they have learned how to divide in 3rd grade. But it's this time where we're taking it further. So we're taking it from the memorizing of facts to how can I use that information for the rest of my life, understanding it and knowing what can be used without grabbing for their iPhone and flipping up that front page that has the calculator on it. Yes. Please come in. Just getting started. This would be a good seat unless you know somebody and you're aiming for them. Either way, it's fine. My generation, I am older than all of you by far. We were just told, we'll take that bet later. In my generation, we were just told to memorize it. I was considered a good mathematician because I could memorize. It really wasn't because I was a good mathematician. The big change in math is the math is the same. We still end up with the same right answers. We still want right answers, but we want the kids to understand it. So when they get into the middle of a problem and they don't know what they're doing, they have the tools to figure it out. So today we're really doing pretty much skills work. This is multiplying with big numbers and dividing with big numbers. Next year they get bigger, and next year they get much smaller. The strategies we're going to go over today work for everything. My husband teaches 7th and 8th grade math. They use these same strategies for simplifying the quantity x plus 2 times the quantity y minus 2. It is the same strategy, and that is the power of this. Can I help you? Do you have a sheet?
No, I need one.
Here we go. Oh, thank you. Taking it right. There are more being made. And math has become a lot about vocabulary. To be able to explain ourselves, if we keep calling it or the answer, the talk can become very jumbled very quickly. Or if I can just say, we're talking about the divisor, and we all know what we're talking about, it's much simpler. So I gave you a cheat sheet. If you open up and just look at your second page, mine is pretty in color and yours is not. This is the math vocabulary of what your students are doing. The expectation is they try to use this vocabulary. We do not test them on it. It is not a vocabulary test, but we're just saying scientists use certain language, poets use certain language, mathematicians should be using a certain language. You've all been exposed to this language. Okay, maybe in Danish, maybe in other languages. But very few of us remembered it because we were honestly never asked to use it. So here's a cheat sheet. You're welcome to keep it. Your 4th grade teachers probably sent home a strategy packet with it, but you may not have paid a lot of attention to it. So quickly, I just kind of gave graphic definitions because it's, again, not that anybody's going to test you on the meanings. The only thing, thank you, and you might need one of your quotient is the answer to a division problem. The only one that I found hard to describe down here was the partial quotient. The way we're going to be dividing today, we come up with these partial quotients. We end up using that terminology for that strategy. Oh, it's the partial quotient way of doing it. So we're going to get started. That's the one with the answers. That's not the one I'm supposed to put up there. I want you to think about multiplication. You got the problem 5 times 14. And you're welcome to think as a 4th grader. What would you know? What does 5 times 14? What comes to your mind? What does it mean?
Well, 5 times 10 is easy, and I know 5 times 4, and then I have the 2 sums.
That's exactly what we would want the kids to say. Could you turn? Actually, could you repeat it louder?
Yeah. I would say, okay, 5 times 10 is easy because I know multiplication with tens, and 5 times 4 is easy as well. And then I add the 2 sums, and then I have my result.
And these are the strategies we've been teaching the kids since 1st grade. Decompose a number so that you can make it easier. Decompose means to just take it apart. I know times 10s, they've known forever, and I know the times 4 because that was a requirement at the end of 3rd grade that I should know my math facts to 10. So if I understand that, I can break it apart. So these are this decomposing of numbers. You might hear them called number bonds. You might recognize that I can take 14 and its components are 10 and 4. Now I can deal with it. I don't have to go 4 times 5, I get 20, I have to carry a 2. I can actually quickly do it mentally in my head. Our end goal is not that all math be done mentally, but our end goal is to recognize strategies that make it easier, and often mental math is the easiest thing to do. So I'd like you actually to write it down. What else do we know about this, actually? That's one way we can find the answer. What else do we know about 5 times 14? Where did pocket your tables? How would you define 5 groups of 14? I just said it. How would you define 5 times 14? Sorry. And that was okay. Walking in there saying I pulled out a calculator is fine. Walking out of here, I hope to hear a different answer.
I acknowledge my weaknesses.
Okay, any other way to describe this if you were just trying to talk to a child? What is 5 times 14? And what would this one be?
14 added 5 times.
Yep.
What would that look like if you were to make little bubbles? Like would it be 10 with 5 in them? Or would it be 5 with...
I would say this is your bubbles.
Okay.
You have 5 groups of 14.
Okay, all right.
And that is the other language that we've really started using, is that understanding 5 times 14 equals is actually very esoteric to kids. It's an algorithm or it's an equation. Understanding that multiplication means 5 groups of 14 takes it into a very understandable place. So, making sure we've got this language again. And I'm going to put in the already know, you've already said this. We know our math facts or have ways of getting to math facts. And that's kind of one of the important things, is attaching something new to something they already know. So I would like you to now build this. And here it is. Your teachers have about 8 weeks to teach. There's a little bit more in the 2 units. And I have an hour. So please, as this may seem very disjointed to a child, we're skipping lots of stuff in between. There's a lot of practice with this. What we're doing now, I would like you to build 5 groups of 14. Your students would know to build it that we're breaking it down by place value. And that the first group, in fact, just build 1 group. The first group, we build by place value. 10s are on the left and the 1s are on the right. So could you please go ahead and build 14 once? If you want to work with a partner, not absolutely, it's actually better if you work with a partner and talk about it. You're welcome to build it yourself. So we have built 1 times 14. Please go for making the mathematics or the arithmetic visible, can you now see exactly the first explanation that was given? I know 5 times 10 and I know 5 times 4. Can you see that after you've built it? This is one of our goals, that they can see it. We also encourage or require mathematicians like patterns and they like order. One of the harder things when we start using the manipulatives is the fine motor skills, keeping the things organized. We work with that. So we now have, and we build and we see, oh, I can multiply 5 times the 10s and 5 times the 1s. We do multiple problems that way, and the kids start getting used to it. So they're not trying to multiply that entire number of 14. They know to break it into the parts. Building it gets tedious. So we want to make sure they can make notations about it also. This grid, for you, I cut it into pieces. Usually it would be a whole piece of paper. Can we draw a diagram of what we just built? And this is where the colored pens on your paper or on your table might help. It's hard to see pencil on a graph paper. So I have one group of 10s and 14. I need a second group, third group, and a fourth group. If it's not labeled, we don't really understand these units. So I'm looking at, I don't have mine on silent, but I don't know anybody who's not at school, so I don't think we're going to break. So if we label this, we can see that we have our 5 groups of 10, our 5 groups of 4. Oh, would you really like 5? That's a wonderful idea. Great piece of trivia. And a funny aside there, one, we all make those type mistakes, please do correct me. So will your child. So you just gently prod them, is that really 5 groups of 4? Why don't we recount it? And what is this value? Well, I know I have 10, 20, 30, 40, 50. I have either counting by 5s, counting by 4s, but I know that this is 20. So we've gone from building it to representing it. Every time we build it, we should be representing it. Sometimes we take some time just to build, but we want them to be able to take that building of it and seeing it. But we're not going to walk around the rest of our life with place 10 value manipulatives in our pockets or graph paper. In 4th grade, they are expected to move to using an algorithm. I'm going to be really specific. The United States has admitted that they made an error in the standards and they say the standard algorithm. There is no such thing as the standard algorithm. Each one of us, how we were taught, probably thinks it's the standard algorithm. There are multiple algorithms that are acceptable. The definition of an algorithm is something, a way of doing arithmetic that you can do quickly and easily, and it follows a pattern every single time. So you are doing it the same way every single time. Problem solving and drawing pictures, we probably do them different depending on the situation. An algorithm, we are to that point, we get it, now we're just ready to get it done. The algorithm that we are teaching here at ASD, or moving them towards, we accept a lot, but we use the one that matches this picture. So we would write this problem as 14 times 5. The answer to a multiplication problem is called a product. So we're going to get partial products. When we first do this, we actually write out what we're doing. We are doing 5 times 4, that equals 20. The next one, let me see, I've taken care of this part of my picture. What else do I have left? I have my 5 times 10, which equals 50. And I now have an algorithm that directly lines up with what I drew and with what I built. Now I want to show you, I gasped the first time somebody showed me this. I can do 5 times 10, which is right here, and I get 50, and then I can move over here and do 5 times 4, and I get 20, and I get the right answer. I was taught it absolutely had to be ones, then tens, then hundreds. That's not true in multiplication. And if we think it through at the commutative property, we know we can move things around. We don't have to. We probably show the kids what I would say is the standard way. We probably show them doing the ones first most often. And I can't even guarantee that. What we want, though, is for any child to start picking the routine. If they're going to go to the largest place value first, they should go to the largest place value first every single time. In a 2-digit number, it's not confusing, but when we get up to 4 digits times 2 digits, you want them to have a pattern that they're following. That's 5th grade. That's not 4th. So it doesn't matter, but you don't want them hopscotching. Oh, I think I'll do the middle first this time. I'll do the tens, then the ones, then the hundreds. You want, the brain likes patterns. As I said, we're probably going to lean towards this one. But if I see a child, just so long I know that they're understanding it, this is absolutely fine. Let's look at the next one. So our problem says I want 4 groups of 27. Would you go ahead and build it? Yours is mathematically correct, but it's because of the area model, especially together, it needs to be seen. They should end with being able to do 4 digits times 1. Okay. We do get picky about how they're built, because ultimately the mathematics behind this is an area model. So 27 would be built with 2 10 sticks. You're not going to be able to see, mine's going to go off the edge. With the 7 that follow, and then we would have the 4 groups of them. This is considered a very small problem in 4th grade, and you can see how it's already getting tedious to build. We do move them along, it's just that we want them to know where that came from. So if we have 4 groups of 27, you've built it, can you go ahead and draw it? We always label the areas. For most students, they would break it down to 20 plus 7, but that's completely understandable. So 20 times 4 would be 80, 7 times 4 would be 28. If a child is struggling with that, this could be broken down into 10 and 10, and we would have 40 plus 40. And as we're teaching the younger kids, 80 plus 28 should not take paper and pencil. They should be able to see that it's 80 plus 20 equals 100 plus 8 more equals 108. As they're understanding that and as they practice it, they will start being able to visualize this in their head, and this would become a mental math problem. I guarantee when I grew up, there was no way I was ever encouraged to do 27 times 4 in my head. I've always done pull out the paper pencil. So the partial products. As we move through this, there are kids that are not going to need to write the smaller equations on the side, but this is the growth that we do. We start with writing them down so that we know what we're comparing. Kids will soon very easily be able to do that mentally also. Done this in class. We are reviewing it with you. I was asked to review it with you because you will be seeing this so many times from here on out. And if any of your students struggled in this, they may be coming home saying, but I don't understand that part. Now, I want to double check that you notice that our first problem was 5 times 14. The second one was 4 times 27. The next one is 36 times 7. So we've swapped the order of the large number times the smaller number. They are very aware, they've built arrays, they know that 5 times 4 is the same as 4 times 5. The first time we did this, I would probably have them build it and we would flip-flop it and see it. This is 5 times 30, what is my number? 7 times 36, this is 36 times 7. So kids get very comfortable with that equality. I don't know whether it's just the way I learned it. I am much more comfortable with the large number going across the top and the smaller number on the side. It works either way. I'm not going to ask you to build this again. I want you to now see, we get to the point that the graph paper is not important. This is called the generic rectangle. We understand, I draw it, how do I say this? It's not, the ratio is not appropriate, but I do draw 30 much bigger than I draw the 6. You'll see on the next one, it doesn't work as well because I still need to leave myself some place to write, but I get it. This area is going to be larger. Just mentally, I know that that partial product should be larger. And by now, I don't really need to write down those small equations. But if a child needs to write them down because they're still struggling to see where they got it from, good for them. They know where they're at and they know what they need to do. There's a small group of kids who keep writing it down forever because they think the teacher wants to see it. We try to wean them off of it. We like personally, we always like teacher-pleasing kids. That's not what we're really trying to develop, though. We're trying to develop confident mathematicians. So if they don't need it, they can do that.
They're still using this generic rectangle in 6th grade, aren't they?
They are now using it in calculus. I can't even show you how to do that one, but they are definitely using it in 6th grade. If you want at the end, I can show you how it's used for polynomials. I can show you how it's especially important for fractions and mixed numbers. 3.5 times 2 1/4 works exactly the same way. Decimals. So yes, this is what we're trying to do. We're not trying to teach brand new strategies at every grade level. Math is interconnected. It builds on itself, so the same strategies should keep working. That just makes me so happy to hear that 6th grade's teaching properly.
Excuse me?
So, yes,
Question. In the last, that's the partial product,
yes.
the way you did it, like you put the units multiplied by 7, which 6 times 7, and then the 7 times 30, and that's the partial product. I'm trying to link the terminology with what I'm
Thank you.
saying.
These would be the partial products, and I think it was more obvious when we wrote, here is the equation, here's the partial product. Thank you, yeah. Partial just means it's part of the product along the way. The brain can hold up to about 4 numbers into its head. I think mine is diminishing down to 3 possibly as I get older. But these problems, 36 times 7, as the kids are getting comfortable with them, they are able to do, oh, that's 30 times 7 and that's 6 times 7, and they can do it in their head. Again, speed is not the goal, but what we want them to do is to be solving problems that matter to us, not just calculating or doing the arithmetic for the multiplication. Today I'm showing you mostly arithmetic. Yes?
So this is an algorithm that represents
That picture.
that feature.
Yeah. It's usually called the partial product algorithm. There could be other names. That's what we would refer to it at this school. Would you go ahead and draw this last one, which is 592 times 8? And my bias, I drew a rectangle that if you use proportion, it would make you put the 592 across the top. That's, unfortunately, I probably shouldn't do it. Pretty soon, we're not going to be giving you rectangles, you'd be drawing it yourself. Yes?
Question on terminology. The word remainder has been vanished. Is that for the symmetry of partial?
Partial quotient is definitely symmetrical the way we'll be solving it. We'll be getting,
I'm saying it's not called remainder.
let me clarify. There are still remainders. We don't put R2 anymore. I mean, R is not a mathematical term. So
Well, we had remainder when we were the division. And then we had fractions, remainders.
yes, we will have fractional remainders, and we'll also be interpreting what to do with those
Now that
remainders.
I understand that it's called a partial quotient.
That would be the algorithm that we teach here.
Partial quotient is symmetry with partial quotient.
Yes.
I see how it's been done.
Yeah. And partial quotient obviously doesn't determine whether it has a remainder, the numbers do. So as I said, you're going to quickly see that things don't really stay proportional. And this is 500, and this is 90, and this is 2, and this is 8. I want to make sure I can read my handwriting there. I don't want to make it so skinny that they can't read it. I know that 8 times 9 is 72. Multiply that by 10, I get 720. And 8 times 5 is 40. I multiply that by 100, and I get 4,000. And then I can add it up. In fact, that one is 4,736. You know, I turn my back and go, I hope it does. So that is what we're doing in multiplication. As I said, these are naked numbers right now. This is just the skill. Most students do not have trouble reading word problems and figuring out that if we're finding the groups, the total of a number of groups, that it's multiplication. It does not tend to be an area of problem for kids. Unlike our next page, let's move on to division. The fact that students, and I would almost say humans, add and multiply easier than they divide and subtract is worldwide. It's far worse in some areas because really the Asian countries have a much healthier viewpoint towards math than Western countries. My little soapbox, there is no such thing as a brain that I'm not good at math. If any of you think that, you need to banish it. You haven't practiced it enough, you haven't been taught properly, you haven't had the reason to learn it, you are fully capable of learning it. All students are. It may take slower, we may have to draw more pictures, but the idea is they haven't learned it yet, and we will keep working. If you feel like you are bad at math, it's just because you haven't had enough practice, and you will get there if you want to. Okay, I'm looking at the time. Visualizing the division. Really, we want you to know that there are two stories to division. 72 divided by 3 can be, I'm not going to draw them all, but it can be 72 groups of 3. How many would there be? Or, I have 3 groups, and I'm going to start putting my 72 inside them equally. And on until we get to 72. Those are two very different stories. And we've been unfair to kids because we haven't made that explicit to them in the past. And so we'll say, oh, it's all about fair share, and then we'll give them a story problem about party bags that doesn't match. And you've got this child going, I just understood fair share, this story makes no sense. And it wouldn't. So we are now specifically talking about those two different stories, and yes, we know that as an algorithm, we get the same answer. But we do need to understand that the stories that go with it, the real life application, can be two different types of stories. So, to be symmetrical, I like that word. What are we doing here? This is almost starts off as a guess and check. If I have 72 and I want groups of 3, I could subtract one group of 3 and I would get 69. I could subtract another group of 3 and I get 66. I'm also going to be here until lunchtime. So I don't need to do it by ones. I could do it by a group of 10. So now I've got 10 groups of 3. I can subtract 30. I have 36 left. As a 4th grader, they would probably subtract another group of 10. I now have 6 left. I sure hope they see that as 2 groups of 3. How many groups of 3 did I end up subtracting? 10, 20, 22, 23, 24 groups of 3. This is a partial quotient. Our final answer is the quotient. It is the answer to the division problem. So when we are down to the actual arithmetic, we talk about it is repeated subtraction of these groups. After the first day, they're no longer going to do it one by one. They're very, very comfortable in their 10s. Some of them are going to immediately go to 20s. Some of them that have amazing number sense may know more than that. Most of them aren't. I would say most of them start with the 10s to begin with.
Have they already started doing this long division? Well, it's not. No.
So I caught you after multiplication. I think they're when I say that today, they could be starting within the next week.
Okay, because my daughter found an old math book from her old Dutch school.
Okay.
And unfortunately, I've showed her how to do it the old-fashioned way. Is that going to mess it up for her?
This is one of the few algorithms that there's very little correlation. The old way, you had to know what you're doing. You had to, it's not based on place value, and that's really why it's gone out of favor. This one, I could, if I don't, especially if I don't have strong number sense, I can start with any number and still keep going. The old one, does everybody know, the old one would look, we would do 3 into 7 is 2, 2 times 3 is 6, and we have 1.
And then 12 times 7.
We're not using place value strategies, we're not doing that. It's not really a problem on this one. It's an awful mess when you start having, I'm not even gonna be able, you know, it's just a mess when you have something like that, because they kind of say, oh, 8 doesn't go into 2, 8 goes into 27 3 times, I'm gonna give that a try. I'm pretty sure it doesn't work, if I guessed my numbers correctly. And so, and I was a 5th grade teacher teaching long division, and until partial quotients came up, I would say I was a failure at teaching it. I know my math. Yes, there are kids that can get it. Once again, those memorizers, they can get it, and there's cute little jingles, something about McDonald's. I don't know, it's like multiply, subtract, and bring, I mean, there's multiply, divide, subtract, and bring down. I don't even remember them anymore, but they were simply a way of memorizing how to do it. And that memorization, as you said, once you get lost, you have no way of getting yourself out of it. We don't even go on to teach it, because I will be honest with you. Nobody that I know would do this with long division. They would pull out a calculator. Calculators do have their place. So we don't really go on to make that, because there isn't, other than the division sign, there's very little that you can correlate between the two. The partial products that I just showed you, I could take what I consider the standard algorithm and I could show you exactly where those two parts fit together. And this one I really can't. So, I mean, I think you just say, well, that was fun. It works. I mean, we have to give it its due. It works. If a child uses it on the test at the end of the unit, we're going to accept it. The problem isn't the child who can do it, it's the other 14 who can't, who are trying to do it. But we accept it. It does work. Along the way, they will be expected to learn this. And it's that whole idea, you need a tool chest with more than just a hammer. So we want to give them multiple tools. But ultimately, if they know how to do the other one, I just wouldn't keep reinforcing it right now.
Because she fell in love with it. She actually wants to do it all the time. Please make me a new sum, make me a new sum. She actually loves the fact that you subtract and you just drag it down, and she loves that. But what I want to know is, how do the British do this? I mean, is this an American thing that you want to have them all these strategies in their toolbox? And
Most
I'm
of what
just
we're getting
curious.
is out of Singapore. So no. I mean, it's really, you know, mathematicians do talk to each other around the world. I would say there are definitely schools who don't believe in this. They believe in memorize it, do it. And, you know, I can't change that. If you believe in that philosophy, ASD is going to be a hard place for you to be. We are looking, this comes from the brain research. And that mathematicians, when you talk to the mathematicians of the world, most of them are not fast. Speed is not the goal. Most of them are very deep thinkers. Most of them can visualize everything they're doing, and they do draw pictures. So the changes are coming now that we can see what the brain does with all the electrodes when they stick them on you. We're getting the research that's proving some of this stuff. And, you know, some of the good teachers, there were a lot of things that we that we knew worked. We didn't know why they worked. Now we're getting the research to back it up now that they can see the brain.
Pick your model. I mean, I can tell you that for the most part, the British school system uses the old-fashioned model. They have one of the lowest math competencies in Western Europe. So always look to Finland, not to the UK.
Yeah. So. Common Core is not about how you teach it. They would say developmentally you should go, they would suggest you use this, but the get me going on Common Core.
No, I know, but I'm just, part of what is a progress,
partners in regards to all of this is like the whole showing the thought process, which we didn't have to.
Right.
So,
Yes, Common Core from NCTM, they didn't make it up, National Councils of Teachers of Mathematics, talk about the practice standards. You need to be able to model it or draw it. You need to be able to show a representation. You need to be able to defend it, and that's that explaining. You need to be, you need to be able to explain and defend your thinking. That is the big change. So what these types of solutions do is they give you a way to be able to defend it. We can't really defend that old division algorithm other than it works. And there are a lot out there that work. Great that once you understand it and you understand everything that's doing, yeah, go use it. I personally am going to use a calculator. It works. But yes,
This is the first area where I see the value.
division.
Division, yes.
Yeah.
That check and guess has always been my bête noire. And having to make all the side calculations.
Oh.
You don't just have the one.
When you
check
start
and guess.
seeing all these multiplication
Yeah.
things over here to figure out where you're going to do it, and most mistakes are made in subtraction. This one right now looks very cumbersome. We did a lot of subtracting, but they were kind of by tens. In 5th grade, we get them to a rather efficient way of doing it. There are some tools that you can develop, and we want to get as little subtraction as possible. So that means we're trying to figure out what is that biggest chunk we can take.
I mean, you can start at 69 already, you see it's.
You can start at 69. Right, no, absolutely. You do 13. 23, thank you. And that's what kids with number sense would do, and that's what we would absolutely encourage. But what we don't want is, and this is where it comes back to when they've been taught the other way, is that you'll get kids sitting there going, and they're trying to find that largest one when they could have subtracted 10 groups 3 times over, and they would have been ahead. I like the mental challenge of that, so that's a fine line with kids. It's like, okay, I appreciate the challenge, I think that's a great idea, but you could have been done 2 minutes ago.
You say mathematicians don't value speed, but tests.
But they do
testers
value
do.
and efficiency and speed, I'm gonna separate. And what the brain research shows is if we are, and this is my last spiel at the end of the day, if a child is struggling to still do the multiplication of 4 times 12, 4 times 3 to get 12, they can't move on to the bigger problem. And by 4th grade, that's an issue. So yes, we do ask them to have gotten their facts. And we use the word automatically. Can I hold that? Because I got a whole.
But this will be faster,
Oh, yeah.
standardized exam than the old one.
And they get good at it. As we said, this was uneven. So on that note, have at it. I know. And if I were the real teacher, I wouldn't even let you have a pencil. I'd make you do it in pen. And this is especially a time when pen is good, because you don't want to repeat your same mistakes that you've already made. What? Yes. Does he have a child who does this? Yep. He likes colored pens though. He likes the I love the colored pens because when you start explaining things, you can start drawing the arrows and see how these two are like. You know, those 4. There, exactly. I would say that's 5th grade.
Oh, it's
Yeah.
not.
And that was that tool I was referring to.
And in grade 4, do you do 2 digit times 3 digits?
They do 4 digits times 1, and they'll do 2 digits times 2 digits.
That's the old way.
Absolutely. So you would do 80 if you did your subtraction right, yes? Yeah, and we're going to talk about that R in just a minute. Yeah, I used to do it in 5th grade. It's because, especially if you've done, it's amazing. You don't tend to repeat the same mistake twice in a row, but if you do something and make a mistake, you move on. It's amazing how they come back to that same mistake again. If you've done it in pen, You can say, oh, I already tried that.
This is his first class starting out to do all that. And now it's just
I know.
kind of like what.
It's so you can keep track of your mistakes. Pardon me? Oh, excuse me, ink instead of erasable. So you're not erasing your changes because we can learn so much from the mistakes we made.
So when it's really been done, then
We can only,
it's just a preference.
yeah. Because I'm not the boss of the school.
So basically,
Or maybe I am. No, you are. So, you know, some of these things that, you know, I would do in my classroom, they're still fairly minor. I mean, the use of color, the use of pens. The use of manipulatives is not up for grabs. We need to do it. That can change a child's understanding. The use of pen is... I'm going to hold off, that's probably in class, I hope so. The reality comes down to at times, it's a time issue. We want them to know it works. Are they really going to check it every single time? I don't know. I don't know what to ask the teachers. I know that they get exposed to that again. I don't know, on every single problem, they're probably not going to do it. Because they're using such large numbers, they're not going to get the practice of the division if they then have to stop and multiply. Okay, so you could attack these differently. At the beginning, most people are probably going to start with 10 groups of 8 on this one. On this one, I would imagine some of us at our level started with 40 groups of 6. You didn't have to, but you could have. It would have gotten to 240. This one, you could go straight to 100. And this is where the practice comes in and that flexibility of numbers. What do you know? On 739 divided by 9, the final conversation that I would want to be getting to is, I know 10 very easily, but 10 is too big. But I can half 10, I mean 10 would be 900. I can take half of that very easily, that would be 450. So I could put, I'm saying this wrong, this would be 100.
We use 150.
50. But we can start using these strategies of I know times 10 or times 100 or times 1,000. I can take half of that very easily, so that would then give me 550 or 5. On the other hand, if I know my math facts, I also see 720. But if I don't, I try something that I do know. I could still do them. I don't know what we do. I mean, by 10 is very inefficient.
We use 80s. 80s.
Yeah, you do 80.
720.
The remaining is just 890 there.
What do we do?
My next thing, let me catch that other question. What?
The remainder you just leave at
No.
the bottom.
No. So what are we doing with these remainders? I can speak for the US. We used to write the letter R and write the 1 here. The letter R is not part of mathematical vocabulary. You won't find it in a math dictionary anywhere. So what do? We want these kids understanding it. What we call this is, I've used it before, this is naked numbers. There is no context to this problem. So all I can do is give the remainder to you. I have 1 out of the next group of 9. And that's how we talk about it. So that's why it becomes a fractional part. I have 1 out of the next group. I need to know the size of that next group. I do believe there was another one with a remainder, wasn't there?
The first one.
That one didn't.
The first one is it.
Oh, we can do
The first one, the second one.
I made her do this. about the errors, make sure the kids are writing large enough and have enough space to do the problem. Trying to do it in a cramped area, we all start making errors. So this would be 17, and I have 7 out of my next 8. Now, you may have used different numbers here. That's fine. Just so long we do want the same end result. Yes?
So the remainder in the second problem is 2 6.
Yes.
Supposed to write 1/3.
In division, we don't tend to, because usually what we should be doing is this should be part of a word problem. And that word problem is going to, you have to interpret the remainder. Does it make sense to make it 1/3? If you're talking about a candy bar, yes. If you're talking about a child, no. So I can't give it. So in general, we don't worry about it. Simplifying fractions is a skill they absolutely need for algebra, but it's not the end all anymore. I mean, in 5th grade, you used to just get the problem wrong if you didn't simplify 4/6 to 2/3. Now you're going to lose some points, but we are going to value the rest of the work that you did. And again, we've now realized naked problems, nobody walks into the grocery store and is given a division problem like this. There is a context to it. It might be how many cans of something you have to buy. So the context is what tells you what to do with that
Bill
remainder.
is at a restaurant and you should have thought about all the people.
No, somebody puts down their American Express and you all walk away. Yes.
So, will they be for the, I don't know which way you're going, but for the top right one, it's 42 with the remainder of 2. So that would be 2 6.
Yes.
Are they required to reduce that?
No, that's what I was just saying. It
That's
really,
where I got lost.
yeah, it really depends on the context. In a blank problem like this, I'm going to speak for myself. I mean, I can't imagine in 4th grade that they would ask them to do it because one, they're doing fractions after this unit.
Oh, okay.
If a child did it, they're right. It is an equivalent fraction, but usually in division, it's not required. Again, it might depend on the particular situation. At the end of the year, I might tell kids to do it because I know they need practice in simplifying fractions. So I want to move on. I'm going to be honest, we're at 9 o'clock. I've got another 6 minutes. Are you good to stay? Because this is the important part. What do we do with those remainders? 143 students are going on a field trip to the Museum of Islamic Art. They need to be put into groups with 8 students in each group. How many groups will there be? I believe the answer is something in 7/8. Oh, you know what? I used problems straight from here. I was thinking. So it's 17 and 7/8 is the answer. We're not going to have 7/8 of a group. We need 18 groups. This is the harder part of the division. We can teach them the algorithm. This is where they have to think. That will be a big part of 4th grade math. You don't talk about 7/8 of a group of kids. So we need 18 groups. The next one says, Daryl is having a birthday party. She bought 254 stickers for the goodie bag. She will be making 6 bags. She likes all of her friends, so she wants the bags to be equal. How many will there be in each bag? That is the second problem on your sheet. In this case, how many stickers are going to be in each bag? There's going to be 42. There's going to be a remainder or 2 left over.
Yeah.
So 2 very different responses to that remainder. And this is where we're asking your kids to be mathematicians and thinkers, not just writing down numbers.
Are you gonna expect them to say, like, there's gonna be left over? I mean, how hard do you expect them to take on?
They're going to make it obvious. They will probably say how many bags and how many. I can't say that.
Because what I find it's very hard, like, I've seen, like, I have 2 kids in middle school, and I've seen them kind of go through some of this already, and like, found really hard for the kids is that when they're stuff in kind of thinking about showing them on the page, they got the answer right, so it's not on there written down. Mark down, like,
When it
or
says-
they'll get like a 2 instead of.
They're getting it to, they are getting it to in communication, because their communication is poor.
But the whole grade is like not even just the communication.
Well, I can't go there, I don't know what individual teachers, I will tell you my philosophy, and I am in charge of it, but I can't guarantee that it's being followed through 100%. We have different standards. In 4th grade, we have a very specific standard about division. If they did the division correctly on, you don't care, but it's 4 MBT.7, they should be getting a 3. We have operations and algebraic thinking, which is the word problem. And if they don't put that remainder correctly, that's where they would get dinged for that. If they don't explain any of it and just write down a number, their communication grade could be a 1. Saying all that, we cannot do that for every single question for every single student because we could never get a whole test graded because there'd be far too many things. So we do make our decisions. But especially the kids who were older and didn't come in from the bottom, middle school's been asking them to explain their thinking for years now. So the extent to it,
They actually have separate grades.
yes, and that's how it should be. I mean, that's what you're saying. They should. If they can do the division, you want that separate grade for communication. It's just it's a tough way to grade. I mean, it's just think about it. One problem is now 4 scores, so we can't do that if you multiply it out. But it is what will make better mathematicians, and the high school teachers are now beginning to say we can see a difference in the quality of their math, which is kind of the best response we have. Okay, your last page. I gave you a blank, this is the blank tens thing if you wanted to practice or if your child were having trouble. It's just graph paper with darker lines on the tens so that you don't have to count out 27. You can just do 10, 20, and then 7 more, or hopefully 3 less. So that's just to make your life easier, and I'm showing you that one. I would like to quickly show you what is on the last page. Automaticity, that is back to that knowing your math facts. They are supposed to leave 3rd grade being automatic up through the tens tables. I don't know how many of your kids are, but they should be practicing them now. That does not mean sitting there and drilling. If you just hold up a flashcard, they read it and they say 12, and they read it and they say 16, it's probably not going to stick. There's a difference between short-term memory and long-term memory. One, if your child likes flashcards, be my guest, most kids don't. But if they are going to do flashcards, you need to be having them read 3 times 4 equals 12. Because just 12 is just a number. What is it attached to 3 minutes later? At least have them saying the equation.
We use bells and electric shocks.
Yeah, that works. On this page, I've given you a few ideas. I think it's Math Playground is a really, really respected website. It has Space Racer, it has Grand Prix, it has many others. It is practicing the drill. It just makes it more fun. To get kids to automaticity, if they pass 3rd grade, they understand what we're talking about, they can visualize it. Speed, limiting their time is important because adding up 3 7 times is not efficient, and they're ready to start making it automatic. All of these games have some sort of speed element. I am not saying 1 second. 4 seconds is considered automatic. That means if you don't know 8 times 8, but you know 8 times 4 and you can double it, you can get to 8 times 8 within 4 seconds. 4 seconds is actually fairly long, and I'm talking orally. Once you put in handwriting, that can skew everything. I believe there are some, how do we say this? I think there are some teachers giving tests on this, and this is what they're trying to encourage your child to do. I would say these are the games that will help your child get to the automaticity. I cannot possibly keep track of all the iPad games. There are a lot of them out there. Although last night when I went looking, I was kind of surprised at how many of them were flashcards. I'm like, oh, come on, you got the way to make this fun. One of these, Well, it says fish, going fishing. I mean, it puts a problem up there and 3 little fish are swimming by and you have to grab the fish. That's correct. I mean, so yeah, it really is drilling. It's not drill and kill, it's drill and fish. So it's just trying to make it that much fun. 5 minutes a night, 10 minutes a night is far better than an hour and a half on the weekend. As soon as tears come, you've probably lost any good that's going on. You really need to keep math enjoyable, because it really should be, because learning is inherently, the brain likes to learn. Yeah.
We do a lot of Excel, but I have my user out.
IXL is drill and kill.
It is.
But it's a lot of practice, and it's good. The one good point about it is it does give an automatic response, so kids know whether they shouldn't be practicing it wrong at
That's
all.
exactly what I wanted to ask. Is something that's more word problem oriented, like a treasure hunt with word problems?
Math Playground is my favorite go-to. Now, this I put under extension. If your child is doing really well in what the class is teaching, making them bigger numbers is not particularly harder for them. What we need to do is start expanding on other areas of mathematics that we really don't cover in class. There are puzzles, there's spatial things. There's one about dipping balls in and you make them polka dot and then striped and then somehow they're green and yellow, and I couldn't figure it out at all, and the kids in my class were, so it was logic. Logic is a part of mathematics. So Math Playground is an extension. All of these I have looked at in general. They have very good reputations. I can't guarantee that absolutely everything in there is good. IXL, I think, has started off as a great idea 10 years ago. I think it's lost its usefulness. Khan Academy is much better because it teaches, and there are ways to use it exceptionally well. Especially, and I haven't used, I dip into it. I have not taught with it for 2 years. There are ways that you can take a test that tells you exactly what you need, you get 5 questions right, and it moves on.
Really?
Unlike
I
IXL.
thought it was not interactive.
Khan Academy?
Yeah, I've only seen the videos on.
Oh, no. The videos are, you've got a choice if you get it wrong. Well, one, they give badges and all that. If you get it wrong, it can give you a clue, which I think they ding you for, or you can take a teaching video that they don't ding you for. So what it's doing is encouraging the kids to take the teaching video because they won't get penalized. So no, it's actually started off as very interactive. Yeah, Khan Academy's good. It can just be frustrating because for me it keeps changing the structure of it. I knew how to use it last week and this week I don't know how to find it. So, but if you're using it constantly, you wouldn't have that problem. But Khan Academy is quite good. And what I didn't put up here is Learn Zillion. Learn Zillion is more of a teaching, not interactive, but teaching videos.
When will they start with Khan in upper elementary?
That would be up to a teacher if they want to use it. You just really don't need it. It would be for specialized cases. I would like to see it used for maybe reteaching, but that's up to a classroom. They do start using it. They start using it also as independent learning in like flipped classrooms. May I ask? I know it went long. On the very back page, I was smart this time and got it not attached to anything else. I'd like to know how the workshop worked for you. Please remember the goal of the workshop is so you can communicate and chat with your child, not so you can teach it. We are expecting to be the teachers here. But could you sit with them? Could you help them? Would you know what in the world they were doing? Knowing we did not teach you the 6-week unit. So if you would please fill that out and rip it off. Yes. What was it? I'm not going to go to there.
No baseball.
Last year I did this with her math, and her father now is doing that. Not really good, you know,
Thank you.
just writing notes. Okay. Thank you so much.
At this point, you're talking, I probably, this comes to how many numbers you can hold on ten. You know, Gary's walks about this division 4 to 6. But yes, these are these people that don't want talk shows. And they can screw things up.
Something about your football.
I go to workshops that he Irma throws it out. It's like, okay, all right,
We're a hot
this
mess
down. I
because
promise
she
you
was
what's
for that. The following week, our coach Pitch got a tooth chip for the bat. I got a tooth chip for the bat before Christmas. We had,
Yes.
we lost one for an injury to the wrist. He got hit with a ball. On Friday, after I got hit, he got hit, another one got hit in the elbow. He's lost, in the last 2 months, we've probably lost.
It's really not.
Oh, like, I would say 10, I know, 10. We do it, yeah,
For me,
here,
I
on
write.
Fridays, yeah.
But it's
Well,
not.
yeah, well,
It's not.
yeah, because Tom was, I'm the division coordinator for the coach Hudson for T-ball, and then I coach a minors team. Minors are
This
9
is
to 10 years old.
where
And we were
we say
worried
that
when
it works, it's a trick.
one of my coaches got,
Yeah.
Because back
plowed
home,
into it.
Like,
Got Tom
yeah,
to
so
go
we
around
always
the
did
house.
it about, like,
So,
I
yeah,
did
we're
have
basically
now.
now shaping injuries for people to come and help put down.
So when I'm
Parents,
questioning
coaches put down, please don't. You easily
This
time,
is
right?
All the injuries.
Yes, all the injuries. And there was one was sliding into second base and he broke his radius and elbow surgery. So I said, we need apparently a big discount. Aspetar, yeah. So we can get a discount. But you have the right.
It was hard. This was.
So think of another way to do it.
What are you doing out there?
It's hard to get into swimming.
I'll tell you what, if we have it, I think we'll find a way.
It's definitely cricket.
Oh, Jim coaches with me on Monday night. Right.
The answers will be up on, we're trying to get a resource together.
Yeah, I didn't have my phone there until late. But this very new one, they were talked about for the 80s.
So I want to hold the national stuff.
Ultimately,
Was this
math can't change.
And the same thing
Yeah.
happened.
I mean,
So
2
the
times
way of
4 is
teaching,
8.
yeah.
Yeah,
The way of
they
teaching.
got away from, what,
Using Venn diagrams, the matter of something like high school.
That's where I wrote pilots. And when my son came home, because it was in British school, I couldn't answer in British school until 2 weeks ago, it was in British school. And we were getting in trouble because this is Mental Math for Pilots. There's a great book, and this is mental, it's called Mental Math for Pilots. It's required curriculum. And this is it. And we were, you know, we were new here in British school, and, you know, we were telling son, you know, no, do, you know, straight up. If you get out to Mental Math for Pilots, yes.
one of the things, and we should do this in the last 10 years.
And, you know, that was our main problem.
There's a
with
thing
Vermont,
called,
because
well,
they
we've done
didn't know what
conceptual
to do.
math, that's not true. We've done
And,
conceptual math, just
and that's okay.
is,
That's okay to
they
not
call it the
know.
arrow way.
You
should constantly be learning and
I'm trying to think, I'm gonna do a simple problem just to make
But
it
when they
easier
just
for
wanted to
myself.
cut him open, we were like, well, tell us why.
So a child can take
Like, what are you
107,
gonna
it's
do?
not, let's do
And
37.
And I'm
I
sure
can
they
subtract
didn't
30 really
explain it
easily,
right, but the
and
doctor
they've been
kept
doing this
saying,
mentally.
"We want an
So it'd be
MRI."
138, now I need to
Then he
explore,
was
so
going
this
for
is
surgery, and I was like,
9.
"No,
I
no,
can
no,
take
we need the
away
MRI
8,
before we would
I
go
get
there."
130, and I take away one more,
So I'm
and
not
I
signing
get
any
100.
paperwork saying,
That's fine.
What
You know,
this
give me-
is we give them a way to write down. what
That's
they're
funny, I
doing.
mean, that's also.
And most of them,
I've
if
always done it.
if you give it to them, if you give them a way to explain their thinking, they will do it.
Yeah.
We haven't taught them a way to show their thinking, and we're not expecting, because that is not an equation. You can't write 168 minus 30 equals 138 minus 8, you know, and this is what they're going to do. You know, and now it's wrong, but you know what the kid is trying to say. So this is one of the biggest things that I've seen in 3 years and go, oh. And now I have something to say.
Mental math for pilots.
Right, and we want them doing it, but we need to see what they're doing, especially if they're coming out one number off. It's like, where do they make that? Because you're so close, you're doing so much right. But for me to be able to help you, you know, it's careless, it's careless. I can tell you, let me see, you've done 9 problems with a careless mistake. What do you think you ought to do to fix that? Versus, they're subtracting the tens place from a hundreds place, but you can see where the error is.
Yeah.
Mental math for cashiers. And I can't tell you how many times I've seen it till already knowing how much
Yes.
is due. And then just crank it out.
And my brother owns a shop, and I have tried, I learned how to count back money, but the computer tells you, I know how to count it back, the computer tells you exactly how much to give back, but you're not counting. I cannot look at that. So I'm equally as stuck in my old way, because I count up, you know, so they get that right amount.
Yeah.
So yeah, we've crippled people with this. And, I mean, in this country, they're not allowed to do anything separate from what they're told to do. So.
My personal thing is here, these relations adding up.
Yeah, but you wouldn't on that one. You
You wouldn't
usually
on
add
that
up
one.
when they're
If-
close.
When they're, oh, I
Yeah.
see, yeah.
And mine was
Uh-huh.
the revelation that I could subtract 38 and 1.
Right, yeah.
It's like, what? I'm allowed to do it? And the truth is those of us who did well were probably doing it keeping our mouths shut. We would never tell the teacher that's what we did.
Extra work.
But you know, the
Yeah.
other great one, look at 1,000 minus 376. That is the dreaded problem, because you're regrouping so many times. But with compensation, well, stop it. So if we had 1,000 and we had 376, okay, what if that was a 10? I mean, no, I want to leave it 1,000. If I take 1 away from both, I now have 999 minus 375, and that is a simple problem.
Yeah.
None of this regrouping.
Whereas I always round this up to 400.
Yeah.
And do
600 and then take it down, yeah. So there's all these strategies, but instead of making the kids write it down in a column fashion, do all this stuff, there's a lot of different ways.
I'm preparing for secondary school. And I'm doing a lot of algebra and a lot of word processing.
Yeah.
What they require. But it's good, another value I see in this is that it's consistent with methodology. You don't have time to be reinventing the wheel. You're at a timed exam. That's where the maths test here is a little realistic. So we have all the time. But we have to.
Okay, but if you go back and look at who the mathematicians and the computer scientists are, they're not the fast ones.
No.
We want to know what they know. I mean, there's maps has
Well, we're
some
testing the
interesting.
wrong way, of course.
Yeah.
That's the other.
Thank you very
coming.
much.
I hope you're doing better soon.
No, 6 weeks. Fracture patella, fracture femur shaft, torn leg.
Fracture patella.
Yeah. It isn't a big one. In all
Why
fairness,
aren't you in a
it's
more rigid cast?
because the swelling.
Because I want to shower.
That too. Yeah, because of the swelling in the side of the ligament. That's of all the 3, the ligament is the worst. It's the most, it will require surgery probably.
You're home with your leg like the other
Yes,
one,
this
but
was,
you're
and I
children.
will be out for the rest of the day. This was a special event. But yeah, back I go, back to the back. No, my husband's out there.
Are you with
Guys?
Yeah, my husband is. I'm retired now.
Oh, nice.
Yay!
My daughter works for Qatar Airways, but in the office.
Oh.
She's a,
It's a
Yeah.
nice little corner.
Yes, and she needs to be.
No, it's fine, I just, thank you.
Oh, thank you. There will be another one for fractions.
Yes.
I was gonna ask.
So it'll come out to you the same way. It will probably be the first week of their teaching fractions, which is like, we're weeks and weeks
Have
away.
you been doing this all?
Not for fourth grade.
Okay.
There has been
Was
very
this
little.
the first one?
I've done it for many other grade levels. I think this is the first one.
Because I kept thinking,
No. Fourth grade is just kind of an interesting time that it's so much based on what third grade's already done. So it's not as unique. We'll try to do more.
no, I'm just happy to get it because, the way we
Yes.
learned
Yeah.
is very different and, I think it's better to be able to support him at home when he's doing his homework than to say, well, but this is how mom does it and I get the right answer.
And you know
Because
what?
then he comes to school
And we're
it's
not-
just confusing.
And we're
And
not
then
doing
we
it
don't know
just
what
to
we're
be
doing.
different.
No.
It is based on research. And most of the parents have come up, oh, that makes more sense. And then they can usually, and then what we do is we take, okay, here it is, the blocks and the pictures and this, and here's two different strategies. Where can you find the similarities? Where is the map the same?
And I understand.
Other than the division problem, I would say you could ask for anything. The division, nobody, I mean, it was just, it works, but it was just.
Well, but you even made a comment during the presentation, when you get 8,431 divided by 37. When my boys have that, I'm like, where's the calculator? Because I don't want to spend the time to do.
And that's why our teaching of estimation is now so important, because you can take calculator control. You need to have an idea
Yeah,
of where
of
that
where it
problem
should
should be. It should be 400, should it be 40,000?
Yeah.
A lot of our keys don't get out, or they double there. So that's where estimation comes from.
Well, there was a workshop, I think you did in the second grade.
I've done a lot in first and second grade.
So that's probably the start for adding some subtraction.
I mean, should I
Break it down all along.
No, not every time.
Yeah.
You know, some of it is there. We've been teaching conceptually for years now. So we've shifted to the Common Core that has beefed up the word problems, has beefed up the
Because that's all we've
explanations.
known. This is our third year here, so that's all we've known.
Yeah,
is doing-
your first year, yeah, I mean, it was conceptual.
Okay.
So there's been a little bit of shift. We're getting the strategies line, okay, by pre-K through 5.
Okay.
It's just, they're in the throes of the beginning of it down there, where fourth grade,
So
good
what
solid
do you do
teachers.
with the lazy child? I mean, because like my 7th grader was in your husband's class, and he loves math, and he really enjoys your husband's class. But the child doesn't want to write, on the word problems. He doesn't want to write everything out, and we want to kill him. We're like, no, just do it. I know you know that 2 + 2 is 4, but can you please show them? So
I mean, if he understands standards grading, if grades make a difference to him. No, and
how?
Thank goodness, I'm kind of glad to hear that. It's developmental, it's.
Because, I mean, he got his report card, and I was just like, and he's like, Mom, it doesn't matter. I know what I'm talking about. I'm like, yeah,
Prove it.
Why are we getting a B? Well, I don't want to show all my work. I don't want to, I don't want to write this long paper.
Work habits and attitude are what the real world is saying the problem of workers are. It's like, you kind of don't get to say, I don't want to do the dishes. I do it.
In second grade, she had,
I've got to check to see whether this is.
test, only because